solve Leetcode question 19, move nth node from end of the list. This is a median Leetcode question. It's a linked list question, and giving the head of a linked list, remove the nth node from the end of the list and return its head. So you have 1, 2, 3, 5, 4, 5 as linked list, and the n equals to 2. So nth node from the end of the list, when n equals to 2, you're counting from the end of the list, that's 4, right? So basically what you're trying to do is remove 4, and then when you return the head, the new linked list will be 1, 2, 3, 5. You remove the 4. And if the head is 1, then you return n equals to 1, and then you remove the nth list from the end, so then the output is empty. So then if the head is 1, 2, and then n equals to 1, so then you remove the last node from the end of the list and you return 1. Here are some constraints here, and could you do this in one pass? And here are the company asked this question. Facebook asked it 23 times in the last 6 months. Great question to practice on. And this, if you look at it, it's a median question, but it's actually not that difficult. If you count, like I mentioned, a lot of the linked list problem, you want to try to solve it by 2-pointer. Basically, you want to have a dummy node, and the dummy node is pointing to head, and then head is pointing to the next node, right? And then head is basically 1. And then you want to set your current at the beginning, your dummy node at before the head, and you want to set your current pointer to the head. When you have a 2-pointer, it's actually really easy for you to go through the list. The idea is that you want to make sure that you continue to move. You want to move when the pref 2-pointer, one is pref is pointing to the dummy node and the current is pointing to your current head. So when you move, so current is here, right? When you move, it asks you to delete the nth node from the end of the list, but there's a technique, and you will know how to do this, is that when you count from the beginning for the current pointer, if you shift the end node 1, 2, right? And then you will move your current pointer to 3. And then dummy, the pref node remain to be at a pref node. So when they have this distance, when you move current here, the next step what you will do is you move the current and the pref together at the same time. When the current reached to the end of the list, the pref will be at the node that before the node that you're trying to delete. The reason you want to get to the node before you try to delete is that you have to be standing at the node before the node you're trying to delete, so that you can point this guy's next node to this guy's next or next. That's how you do it in the linked list. And this is 1, 2, right? 3, 4, 5. So if you look at it, it's basically you continue to move current, but without moving the pref, and you move current nth node. So basically 1, 2, 2. So the current is at 3, right? And then at this time, you continue. So you already put things in the right position. Then you want to continue to move both pointer. And then you just continue to shift while current still exists. And then you shift it to 4, and then shift to 5. I'm trying to move to the right position, and then you move one step. Current is no already, right? Because after 5 is no, and then the pref will be at 3. When the pref is at 3, and then you can point the pref's next to pref next or next, which is 5, and then this way you will be able to delete the node 4 in this case. And I will show you how to do this in code. And basically at the beginning, you want to set a pref, basically a dummy node. The dummy node is also easy for us to return the head. When you return dummy.next, that's basically the new head, and pref dummy, and if you see the definition of list node here and you want to define it, the parameter is next equal to null. So you want to set next equal to head. So that's a node that you added before the head, right? And then you want to set your current node to head. And the first thing you need to do is remember what we did first is that you already put them in the position, right? I want to continue to move current. So while current exists and n bigger than 0, what I wanted to do is current equal current.next. I want to continue to move current to its next value until that n equals to 0. So I'm gonna do is every single time when I move current to next once, and I'm gonna decrease n. So until decrease n to 0. So I move current to the right position, which is where 3 is. So once I move the n to the 3 position, I'm gonna shift pref and current together. So how you shift them together is while current. So while current, until that it doesn't exist anymore, what you do is current equal current.next and pref equals to pref.next. So you just basically each time you shift one by one, but they are still maintaining this distance difference, which is n in between them. So in that case, when the current reach to the end of the list, pref will be located at the node, one node right before the node that you need to delete. So when you reach that node, right, what do? You want to set the pref.next. So pref is at 3 here, right? Pref.next originally pointing to 4, right? How you delete node in the linked list is set pref.next is equal to pref.next .next. So the pref.next node originally was 4, right? You just set this pointer to the next.next. That's 5. By doing this, you already deleted the node 4. At this time, we already delete the node. We achieved what we need to do. But in the end, you will have to return the linked list, right? And I'm not going to do head because I'm just going to do. That's the benefit of using the dummy node. So all you need to do is just return dummy.next and it will show you the linked list. Yep. If you think this is helpful, please like my video and subscribe to my channel, and I'll see you with more Leetcode questions soon. Bye bye.